Welcome to The Explainer. Today, we're looking at a really clever new way to make AI agents smarter, and the secret isn't just about throwing more data at them, it's about teaching them to actually learn from their own screw-ups.
So let's kick things off with a question that I'm sure you've asked yourself. You've got this incredibly powerful AI, right? But then you ask it to do something that seems pretty simple, like, say, buying something for you online, and it just fumbles. It gets stuck. Why on earth does that happen?
Yeah, it's a super common frustration. An AI might try to put something in a drawer without opening it first. Or it'll get totally lost in the middle of an online checkout. These are the kinds of mistakes we see all the time, and they're pretty predictable. But a new research paper outlines an amazing way to turn these exact failures into permanent learned skills.
Okay, so to really get why this new solution is such a game changer, we first need to understand the problem and, well, the pretty flawed way we've been trying to fix it up until now.
So the real problem here is that while large language models are fantastic at things like writing and summarizing, they can really struggle when they have to interact with the real world. Any task that means they have to remember a goal, juggle multiple steps, and react to new info, well, that's where they can easily get tripped up.
The go-to solution for this problem is a technique called retrieval-augmented generation, or RAG for short. Honestly, the best way to think about RAG is like giving the AI a cheat sheet for a test. Whenever it's doing something, it can look up information from this outside database to figure out what to do next. It's like an open book exam.
And look, in a lot of ways, this works. It definitely makes the AI more accurate and lets it do things it wasn't originally trained on. But, and this is a big but, there's a major downside. Using that cheat sheet adds cost and makes things more complex every single time the AI does the task. It basically creates a permanent crutch. The AI never actually learns the material. It just gets really, really good at looking up the answers.
So this leads us to the million-dollar question, right? What if the AI could get all the benefits of that cheat sheet, but without having to rely on it forever? What if it could actually, learn the lesson?
And this is the genius idea behind the new research. Instead of using RAG as a permanent crutch, they use it as a temporary teaching tool. Think of it like training wheels on a bike. You use the RAG system to create these perfect, flawless examples of how to get a task done. Then, you use those perfect examples to train a brand new AI. But, and here's the really clever part, you take the cheat sheet away while it's learning.
By doing that, you force the new AI model to actually internalize the knowledge. It can't just look up the answer anymore. It has to learn the logic behind the actions. The whole point is to make the AI permanently smarter, not just better at finding information in the moment.
Okay, so how do they actually pull this off? The research lays out this really practical 4-stage pipeline that basically creates a self-improvement loop for the AI. It all starts by just letting a basic AI try a bunch of tasks and, well, fail. They just collect all the mistakes. Then, a super powerful model like GPT-4o analyzes those failures and creates these general reusable hints. Next up, a teacher AI gets these hints at the start of a task, which helps it create a perfect walkthrough from start to finish. And finally, this is the magic step, a new student AI is trained on these perfect examples, but with the hints totally removed. This forces it to distill the knowledge and figure out the right way to do things all on its own.
So what does one of these hints actually look like? It's a really simple general rule, like this one. You'll notice it uses placeholders instead of being super specific. This hint wasn't written by a person. It was automatically created just by analyzing a failure, where an AI probably tried to put something in a closed box. This makes the advice reusable in thousands of different situations.
And I've got to say it again, because this is the absolute key to the whole thing. Taking away the hints during the student's training. This is what makes it so powerful. The model can't just memorize a rule. It has to actually develop an intuition for the right way to do things. It learns why it's a good idea to open the container first.
So the idea sounds great on paper, but does this whole teacher-student thing actually work in the real world? Let's look at the numbers.
In a simulation of common household tasks, the new distilled model, as they call it, achieved a pretty staggering 91% success rate. I mean, to put that into perspective, that's a huge jump over the other methods. Let's break that down. So, the base model with no help, it gets about 80% right. The model using the RAG cheat sheet does a little bit better, around 82%. But our new distilled model, the one that learned from the teacher, It just blows them both out of the water at 91%. So not only did it learn the skills, it actually did better than the system it learned from. That tells you it's really internalizing the principles, not just copying answers.
But hold on, the benefits don't stop with just being right more often. This new model isn't just more effective, it's also way more efficient. And in the world of AI, efficiency means saving time and, you guessed it, saving money.
In another test, this time in a simulated online shopping world, the new model used 47% fewer tokens than the original base model. And since tokens are basically the words and pieces of words that AI models have to process, using way fewer of them means the model runs faster and a whole lot cheaper.
And get this, it's even more efficient than the RAG model it learned from. In those household tasks, it used 17% fewer tokens. And that makes sense, right? It no longer has to process the extra text from the hint, and it just makes fewer mistakes, so it finishes the job in fewer steps.
Let's just look at this table from the shopping task, because it tells the whole story. The base model scored about a 61, using almost 8,000 tokens. The RAG model with the cheat sheet scored higher, a 67, but it was the most expensive by far, using over 11,000 tokens. And then you have the new distilled model. It got the highest score, over 72, while using the fewest tokens by a country mile. It is literally the best of both worlds.
All right, let's zoom out. What does all this mean for the bigger picture of how we're developing AI?
So, why is this such a big deal? Well, this research gives us a clear roadmap for creating AI agents that are way more capable and self-sufficient. It shows us how we can take these temporary fixes, these crutches like RAG, and turn them into permanent, baked-in skills. It proves we can build these abilities directly into the model, and the result is an AI that's smarter, faster, and cheaper to run.
And that really brings us to a final, pretty exciting question. This whole technique was used to replace the RAG cheat sheet. But what other crutches are we giving our AIs right now? What other temporary helpers could we use this same method on to transform them into deeply learned permanent skills and make our AIs truly intelligent?